Okay, so in this problem, we got a linear function. Here, my y-intercept is 1, my x-intercept is 2. The graph, if you see it, guys, if you're a student watching this thing starts at 1, goes 1 down to the right, 1 down to the right. Y equals negative 1 half x plus 1. So you just got to get good at doing. And just ask us to describe what's going on here. Y is a function of x, y is a function of x. Does not represent y as a function. Those are out. Those aren't it. This is one of the two. Because the x values correspond to exactly one y value, the x value corresponds to multiple y values. There's going to be one. It's just telling us, is this a function, not a function question. So if I look at if I do that and I go to none, one value for x. That's the reason I was asking for. Anywhere I pick an x, I go up, there's one value. There's nothing else. If I pick another value for x, this is a 2. If I pick x equals 6, I get this guy. So no matter what, as I plot my table, x always has a different number. It can actually have the same number for y, but x will never repeat. So if I start here at negative 4, I know my y is 3. If I start here at negative 2, I know my y is 2. At 0, it's 1. At 2, it's 0. At 6, it's negative 2. The y is never going to repeat. So in other words, well, it can repeat, but the x won't repeat. So there is no another 6 value with a 3, for example. There is nothing up here that's a 3. So this graph doesn't do this. Straight down, they keep going, right? So once it does that, it fills that vertical line test. So it's only it's a 1-to-1 correspondence, right? And again, the y can repeat all day long, but not the x. And that's it. That's the problem. First answer is one thing. So you cannot have multiple y values. You can only have, because x has exactly only one y value. That's it. So the answer is A. Easy test question. Don't miss it.